All right. I believe we got to solving each equation by the quadratic formula yesterday, yes? So, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's our quadratic formula. And we're going to use it to solve these here, because for these two here, we want to solve each equation by the quadratic formula. So we're going to use that equation specifically. And to solve using the quadratic formula, the first thing we need to do is get the equation equal to 0. So we're going to add 5 to both sides. Minus negative 4x squared plus 3x plus 5 is equal to 0. Okay. Thank you. $26. Now, as we saw, especially in doing some of the ones in the note sheet, having the a value be negative ends up giving us a denominator that is negative. So to make things a little bit easier, we're going to divide by -1 to make the value of a go from negative 4x squared to positive 4x squared. Our 3x is now negative 3x. Our positive 5 is now negative 5. And well, 0 is still just 0. For completing the square, yes. For quadratic formula, we can keep a as 4. It just works out nicer if it's positive. Now, if it had started out as a positive number, we don't have to do anything with the sign. We can just leave it as is. So we have our a, b, and c. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, our a, b, and c is coming from ax squared plus bx plus c. A is the number in front of x squared, b is the number in front of x, c is the constant term. So when we plug it in, negative b would be negative 3, plus or minus the square root of negative 3 squared, minus 4 times a, which is 4, times c, which is negative 5, all over 2 times a, 2 times 4. Now our negative 3 would be positive 3. The denominator, 2 times 4 is 8. Now at this point here, I would plug everything inside the radical into the calculator first. Clear all that out. Clear. So we have parentheses. I just lost the middle term. Negative 3 squared minus 4 times negative 5. Negative 5, giving us 89. Questions on how we got to this point here? If the radical is simplifiable, we can simplify it in any way, shape, or form. We need to simplify it. The 30xs will tell us if we can simplify the square root of positive 89, and it is square root of 89. So it doesn't simplify, so that there is actually our final answer. Like we had yesterday, the square root of negative 20, bless you. The negative would come out as I, square root of 20 is 2 square root of 5. So the square root of negative 20 would simplify to 2i square root of 5. If the radical can reduce, we want to reduce it. I'm not going to dock you points if you don't reduce the entire fraction, because if the top two numbers where 3 and square root of 89 are have a common factor with the denominator, I'm not going to make y'all reduce it. If you do, that's fine. But if you at least get to simplified radical form, I will take that as well. Questions on 26 and 27? We feel good with quadratic formula for the most part. 28, 29, and 30. Find the value of the discriminant. Describe the type of solutions and find the value of the solutions. On the test, I'm not going to ask you to find the values. I'm just wanting you to find the value of the discriminant, which is our b squared minus 4ac, and describe the types. Now, there's only 3 situations, or 3 values, that the discriminant can be. It's either greater than 0, it's positive, it's equal to 0, because it is 0, or it's less than 0. If it's positive, we have 2 real solutions. If it's equal to 0, we have 1 real solution. And if it's less than 0, we have 2 complex. I think someone came into the building and the air pressure buffeted it. The door. Questions on this here? So, when we look at the first one here, 28. To find the discriminant, we do need this equal to 0, so we would now we just plug it in. Now, if we were trying to solve, I would make a be positive to go from there. But since we're not solving, we just want to find the value of the discriminant. We can just go from here. So a is -4, b is 5, c is -10. b squared minus 4ac, 5 squared minus 4 times -4 times -10.
No, I was just confused because oh, never mind. I didn't see the equal sign. Because I thought you were subtracting the -4x squared on the same side.
Okay.
I saw the
Figured it out.
Yeah.
And if we type it in, we get -135. So the value of the discriminant for this one is -135. Since it is less than 0, we have, 2 complex solutions. That's it.
What about the one with only 2? 29. Oh, it doesn't have.
Is it equal to 0?
Oh, so C or B? C. No, B. B.
So a is -2.
C is 0.
B is -1. C is.
Wait, why -1?
Because it's the equation equal to 0. Well, the starting equation was equal to x. We have to move it over to get it equal to 0. Now, if one of them was missing completely, it would be 0. b squared minus 4ac. So -1 squared minus 4 times -2 times -6. Is -47, which gives us 2 complex solutions. That's it. Questions on this here? Questions on any of those so far? Questions on number 30? We good with 30? 31 through 33, find the value of C and then find our perfect square trinomial, factor it. Well, C is equal to B over 2 squared. So here, C is equal to B over 2 squared. So that B is indeed negative 24. So we get negative 24 over 2 squared. Negative 24 divided by 2 is indeed negative 12. Negative 12 squared is 44. So our trinomial, our three-termed polynomial, is x squared minus 24x plus 144. Now, when we factor this, set of parentheses squared, we would have x. The number that goes inside is our minus 12, because we put the number that was inside the parentheses before we squared it in finding C, giving us x minus 12 squared. That's it. Because this is really one of the key steps to completing the square. Let's look at 32. X squared plus 29x plus c, the value b is 29. Can we divide 29 by 2? I mean, we can we? But it's a decimal. If it's a decimal, leave it in fractional form. So since it doesn't divide, go on and square it. 29 over 2 squared is 841 over 4. So it means our quadratic for this here is x squared plus 29x plus 841 over 4. Now we need to factor it. Number that goes in there, it would be 29 over 2. And since it's positive, we would say plus. And that's it. We would do the same thing with 33. Questions on 31 or 32? Are you comfortable with these here? Powers of I. To find what these simplify to, I to any power. We take whatever the exponent is and divide it by 4. There's one of 4 different options we can get. We can get a decimal that's 0.25. And if we get that, it's going to reduce to I. If we get 0.50, it'll reduce to negative 1. 0.75 is going to reduce to negative I, and 0.00 will reduce to 1. And that's it. So 2,874 is right there. So we'll take 2,874 and divide it by 4. Divided by 4 is 718.5. We don't care about the 718, the 0.5, so it is negative 1. I wonder something. The 3 of y'all, academics, remind me about this in a minute with I. There's something I do want to show y'all. 6971 divided by 4. So we can do this here. 6971 divided by 4 is 1,742.75. Because the main thing we're focused on is the 0.75, which is negative. Questions on this here? questions on any of this here so far? Question on A, B, or C? How to do any of those there? We good with A, B, and C? All right, questions on A, B, C, D. E. A, B, C, D. So if you want to see the full worked out version, I do have it on the video, the full video, but we can type it completely into the calculator and let the graphing calculator do it for us.
How do you put I?
Second decimal in the graphing calculator. So B, 7i minus 27 plus 3i minus 2. Negative 29 plus 10i. We'll also do subtraction. Whatever it is written as, type it in exactly as it is and let the calculator do all the work for you. Because we can even say E, 189, second I, minus 361, second I squared. I put W instead of minus, plus, parentheses, 71, second I squared, minus 38, second I to the fourth, enter is 252 plus 189i. So we just type it in exactly as it's shown and go from there. Almost. Multiplication. We can type it in. Even our that's H. If we look at K, even with having I to the fifth or I squared, it still does them just fine. We have to plug it in. Question on addition, subtraction, or multiplication. So L, to type it into the calculator, we have to rewrite it as, or type it in as 8 minus 4i, our division key, 3 minus I. And we have to put the numerator and denominator in parentheses. And then we have to hit math, enter, enter. Because math, enter, enter will help things a little bit. Our 8 minus 4i divided by 3 minus I is this here, math, enter, enter. Math. When we get 14 fifths minus 2 fifths I. Yes? Yep. We could also do M, 4 divided by 3 minus 4 I is this here. Math, enter, 12 25ths plus 16 25ths I. I want you to put it as a fraction, mainly because it's 3 keystrokes, math, enter, and you get it to a fraction. Questions on this here? I'd say if it was a more arduous process to get it from decimal to fractions, I would leave it as a decimal, but since it's literally 3 keystrokes afterwards, I want you to put them as fractions. Any other questions on L or M? Any questions on NOP? Nope.
Oh, you did the cross. Oh, yeah, I got it.
Yeah, NOP. Nope. Yeah. Any other? So that brings us to the last part. I need to add these to the sheet, the slides. Q. We want to find the complex conjugate, which is, what's complex conjugate of 4 minus 3i?
4 minus,
Ever.
oh wait, plus minus, plus,
Wait,
and 4, oh, 32.
okay, so Q is.
And then you talk
So the instructions was find the complex conjugate. We found it because the complex conjugate of 4 minus 3i is 4 plus 3i. And we change the sign in front of I and find their product. Product is which operation? So we multiply them together. And again, we can do this in a calculator. 4 plus 3i times 4 minus 3i is 25. So the complex conjugate for this one here is 4 plus 3i. Its product is 25. And that's it. R. 18 plus 14i. Its complex conjugate would be?
18
minus,
Then we just need to multiply them together. Maybe a little bigger than 45.
Oh, yeah.
520. What would the complex conjugate be for 8i? Negative 8i, and its product would be?
What's 8 times 8?
64.
So 64.
Well, it'd just be 64. Because 8 times negative 8 would be negative 64. I squared, I times I would be I squared. I squared is negative 1. So negative 1 times negative 64 gives us. Questions on any of this here? Because that is the end.
For,
What was it?
Number 3. Problem number 3. Is there a greatest common factor?
Yeah.
So we'll move on to step 2, our 2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite.
You have to do the factors of both 3 and 6.
Factors Well, the sides would both be positive because third term is positive. Same. Middle term is positive, so both positive. Factors of the first and third term. Factors of 3h squared, well, we'll have h and 3h and h, because the only factors of 3 are 3 and 1. Only factors of h squared are h and h. Factors of 6 are 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3. We have to put the 2 with the 3h because we can't put the 3h with the 3 because there was not a greatest common factor. So there can't be 1 in either parentheses. Last thing we can do is check.
No, I did the other way.
So I was right.
3h times 3 is 9h. 2 times h is plus 2h, which gives us 11h, which is the middle term we wanted. So those are our factors. Any other questions on the review sheet? Okay. I'm going to stop the video here.